Hello my friends, and welcome again to this new video in our series Mr. Udaid Chemistry course, into which my friends we are going to continue answering questions of the British syllabus Pearson Edexcel International GCSE. Today the questions, my friends, as we know, from 2024, the 17th of May, the subject is chemistry. My friends, today we are going to answer question number 8. The question is about crude oil, as we see here. Describe how crude oil is separated into fractions by fractional distillation. I'd like to remind you, my friends, of fractional distillation. We said that fractional distillation is a physical procedure into which we have a mixture of liquids. These liquids are soluble into one another, and we want to separate them depending on the differences between their boiling points. And the procedure steps here, as they see, the procedure steps. Step number 1, heating. So we heat the crude oil until it turns into gas or vaporized. The second step, my friends, here is entering the column. This hot gas enters, means the vaporized crude oil enters the bottom of the fractionating column. In step number 3, the temperature difference. As you know, my friends, we separate them, the mixture components, we separate them according to their boiling point, so there will be differences. So the column is hot at the bottom and gets colder near the top, like this. Here we have very hot, for example, let's say 500 Celsius. The other part here is 400, the other part here is 350, for example, then 300, until we reach, for example, 25 or 50 Celsius degree. So there will be a gradient in temperature. Then condensing. After we separate the gases, for example, here we have the gas is separated at 350, and here the 300. We collect this gas here and we condense it alone, and we condense the gas coming from the other let's say hole here. So we condense each gas alone so that we make them liquid again. And finally, my friends, the short chain hydrocarbons with low boiling points will come out near the top, and the long chain hydrocarbons with high boiling points will come out near the bottom, because generally the longer the chain becomes, the higher the boiling point will be. As a final piece of advice, my friends, here I would like to give a quick tip to remember. We have 4 main points in this question to answer. We have the journey of the crude oil. Number 1, heating. Number 2, putting in the bottom hot to cold column and rise and condense the boiling points. So that if you don't want to use my words, you can use your own words, but you have to pay attention for these 4 main points around which the examiners concentrate and want to give you the full mark. Now we go to question B. In question B here, explain why cracking is important process in the oil industry. Generally, my friends, as we spoke before, when I explained to you the fractional distillation, we talked about 2 types of hydrocarbons. The first one is the short chain hydrocarbons. Generally, the short chain hydrocarbons from C1 till, let's say, C8 or sometimes C9, while the long chains are from C9 till C40 or C50, depends on the type of petroleum. The geographical area plays a very important role in determining the components of the mixture. The short chain here are useful. We can use them as a fuel for cars, gasoline. We have the kerosene comes out of them, maybe the diesel. We have the methane, the butane, cooking gas, while the others, which are the long chain, are useless and they cannot be used as fuel. So we need to take them, like this example here. We have C15. C15 is a little bit difficult to be used as a fuel because it's very thick and it's inflammable. This means cannot be burnt easily. So we break it down by heating it till 500 Celsius degree, if I remember, and we use aluminum oxide as a catalyst, so that we break this long chain useless hydrocarbon into short chain useful hydrocarbons. And as we see here, my friends, the three important points. The first one, fractional distillation produces more long chain hydrocarbons than can be used directly, so we break them down into short chain. The cracking breaks down to produce shorter chain alkanes. Here, number one, alkane. So we get shorter chains of alkanes, like this one. This is an alkane, so that we can use them as a fuel, like petroleum. And some alkenes here, cracking also produce alkenes like this one and that one. Teacher, how did you know that this one is an alkane? How did you know this is an alkane? It's easy, because as you see here, we have CN, H2N plus 2. This is N here is 8, C8 here, C8H18 means 2 multiply 8 plus 2. This is 16 and 2, 18. That's why I know this is an alkane, while I know this is an alkene, my friends, because alkenes, they have the common formula, general formula, CnH2n. Look here, my friends, if we substitute N with a 3, we will see that C3H2 multiply 3, H6, which is exactly C3H6. What we have here, again, CnH2n. Let's substitute N with 2, C2H2n, which is 4. This tells me that those both are alkenes, while this one is an alkane. So, my friends, alkanes and alkenes are produced by cracking. So, in general, we use fractional distillation in order to break down long chain useless hydrocarbons in order to get short chain hydrocarbons, which are alkanes and alkenes. Alkanes are used as petroleum, while alkenes are used as polymers and to make plastic. Final question here. Fuels obtained from crude oil may contain impurities. This is correct, my friends, generally, because the long chain useless hydrocarbons generally are accompanied with chemical elements like sulfur, like nitrogen. Generally, a lot of students could ask me, teacher, you told us that petroleum, or the components of petroleums, alkanes, alkenes, and alkenes, are hydrocarbons, and we call them hydrocarbons because they are made up of only carbons and hydrogen. This is true, my friends, but when we have long chain hydrocarbons, these long chain hydrocarbons seduces the other elements like oxygen, like sulfur, like nitrogen, in order to get in touch with them to be included into their own structure. That's why we say the fractional distillation makes fuel like alkanes, short chain alkanes, but these short chain alkanes are generally accompanied with impurities. Fuel contains sulfur impurities. When burnt, when we burn it, the fuel, when we burn the fuel, the sulfur will be burnt with it, making sulfur dioxide, and sulfur dioxide could be also oxidized by oxygen to give sulfur trioxide, and this sulfur trioxide will travel to the atmosphere, where it will meet the clouds. And you know, clouds are made up of water, so this gas is going to be dissolved into the clouds, which are water, in order to make what? Sulfuric acid, which is aqueous, which is dissolved in water. And when the rain when it rains, the rain will contain H2SO4, and we call this acid rain. I hope, my friends, you have enjoyed and learned from this video. In the next video, my friends, we're going to answer questions number 9 and 10 together.